Hi everyone, and welcome to Cognify. So in today's video, we'll be looking at some functions. So we are given two functions. We've got f of x, which is our parabola, and g of x, which is our straight line, and both of them are sketched below. And we are told that a and b are the intercepts of f. So we've got a this side and b this side. So these are the intercepts, right? So the function, the parabolic function, cuts the x-axis at 2 points. Furthermore, C and D are the y-intercepts of f and g. So we've got D here, right? Then we've got C. So C here also acts as a turning point for the parabolic function, right? So it acts as a parabolic function. It also intersects the y-axis. And the straight line also intersects the y-axis. And K is a point on G such that BK is parallel to the x-axis. Okay, we've got BK here parallel to the x-axis. But I guess what they mean is perpendicular to the x-axis and parallel to the y-axis. And F and G intersect at A and E. Okay, so these are useful information to have. So now let's look at the questions that follow. So in question 5.1, we are required to write down the coordinates of C. So if you can recall, C, if we look here on the graph here, right, C is the turning point of our parabolic function. So now at that point, we can clearly see here, since it's intersecting the y-axis, right, the x value of our parabolic function is 0. We can clearly see that, right, from the sketch. Okay. So now, since we know what the x coordinate is, okay, we can simply substitute this value into our function. So our function is x squared minus 4. So we can substitute 0 in x's place. Okay, so now we get minus 4. So now the coordinates C would be what? It's at 0 and minus 4. And we can clearly see that, right? That point C is below the x-axis. So now that is 5.1. Okay, we've got the coordinate. Now let's go to 5.2. So in 5.2, we are now required to write down the coordinates of D. So now if we go back to our sketch here, we see that D is a point on our straight line, right? So now at that point, we know that x is also 0, right? Because you can clearly see here it's intersecting the y-axis. Now we need to substitute this value into our function g of x. So g of x is defined as minus x plus 2. So we can substitute 0 in x's place. And we get 2. So the coordinate of D is at 0 and 2. So now, let's go to the next question. In the next question, we now want to find the length of CD. Okay, so in the previous two questions, we found coordinates of C and D. So now we can utilize those points to find the length of CD, right? But which part of the coordinate do we use? So since we are dealing with a point that lies on the y-axis, right? So we are looking at vertical differences. So we're going to be using the y value, okay? So what we do is we take the top value. So the length of CD, right, is going to be what? So we take the top value, which is 2, then subtract the bottom value. And keep note, you need to put the negative sign, right? Because we want to find the difference, okay, between those 2 points. So this is 2 plus 4, which is equal to 6. So you can write it as 6 units. If the units aren't given, you can just write it as units. So now that is 5.3. Okay. In the next question, 5.4, we now want to find the coordinates of B, which is another point, right? And B, what you'll notice is that it's a point on the parabola. And another thing is that this point is the point of intersection, okay, between the parabola and the x-axis. Not only this point, but another point here. But for this question, we want to find B. So when you want to find uh, these coordinates, right? Given that our parabolic function intersects the x-axis, we can conclude or we can deduce that y is equal to 0. And you can clearly see that because that point lies directly on the x-axis. So now given that y is equal to 0, okay, we then equate this to our function f of x, right? So what does this mean? It means that x squared minus 4 is equal to 0, okay? So here we're going to get two values, right? So x is equal to 2 or x is equal to minus 2. So for this question, we want to find the coordinates for B. And we can see here B lies in the negative x-axis, right? So now we're going to be discarding this one here, right? So we're going to be taking this. So the coordinate of B will be minus 2 and 0. And that is basically it for question 5.4. So now let's continue, okay? Next, we'll be looking at question 5.5. Now, in question 5.5, we want to determine the coordinates of E, okay? And what you'll see is that E is actually a point where our straight line and our parabolic function cut. So if they cut, what does that mean? It means that they share a coordinate, right? Both x and y. So to solve such questions, you simply need to equate both functions, okay? By equating them, we'll then be able to solve for x. Once we solve for x, we then substitute that value into either of our functions and find the corresponding y value. So now, let us equate them. So x squared minus 4 is equal to minus x plus 2. We transpose the terms to one side, right? So we'll have x squared plus x minus 4 minus 2 is minus 6. Okay, so now here we need to find the factors, right? So we'll put 1 here and 6. These are got from here and here. So factors of 1 are 1 and 1. Factors of 6, for this example here, we'll use 3 and 2. Why? Because when we cross multiply, okay, this coefficient here in the middle, we put it here. We assign a positive to the 3 and negative to the 2. So this helps us find the factors, right? So our factors here will be x plus 3 multiplied by x minus 2, and that is equal to 0. So now we can solve for x, right? We have x is equal to minus 3 or x is equal to 2. So we've got 2 points, right? 1 point, x minus 3, that corresponds to which point? It's a negative x value, so it's going to be for this e here, and then the positive is going to be for this point here. So now, for this question, we want to find coordinates of E, okay? So let us take this value here and substitute it in either of our functions. So I'll substitute it in f. So f of minus 3 is equal to minus 3 squared minus 4. And this is equal to 9 minus 4, which is equal to 5. Okay? So now we've got an answer here, right? So what is our coordinate? Our coordinate is then minus 3 and 5. And that is basically it for 5.5. So now let's go to the next one, right? 5.6. In 5.6, we want to find values of x for these cases here where our function f of x is strictly less than g of x. So what that means here, right? We just have to refer to a graph here. So we want to find values of x where g of x, which is our linear function, is above f of x. So if you look at our sketch here, right, we can see here that from this point here onwards, right? So this point here at A, and if we go to the right, we can see here that f is above g, so it won't apply there. So now let's look at another point in our graph, right? If we look at between A and B, or rather A and E, we can see that our linear function is above our parabolic function. So those 2 points are what? Okay, so it will be, so it's going to be x is strictly less than, the point here that we found was 2, right? Strictly less than 2. And the point we found here at E for x is minus 3. So within this range here, right, our function g of x is strictly greater than f of x, because you can clearly see here, right, between these 2 points here and here, okay, the straight line is above. If you are asked to find the opposite, right, where f of x is strictly greater than, then it will be this point here onwards. So it's basically x strictly greater than 2. But hopefully that makes sense. So this is for question 1 from 5.6. Now with the next one that follows, we now multiply, right? So f of x times g of x greater or equal to 0, okay? So now with this question, right, we need to now look at our functions and look at points where when we multiply both our functions, we get 0 or strictly positive value. So that would apply where both of our functions are at 0, which what that means is that at the intersect here, right, with the x-axis or above. But that would have to apply to both functions. So now if we look here, right, let's look at x greater than 2. So it's this part here, right? For x greater than 2, we know that our function, let's just say greater or equal to our function f of x, right? What would it be? Our function f of x will be greater or equal to 0, okay? But our function g of x will be less than or equal to 0. Why? Because when we go past x is greater than 2, right? Our function, the linear function, is below the y-axis. So it has negative values. So this should give you an idea of how you go about doing this, right? So for this one here, right, we take f of x times g of x. What this means here, right, is that both has to be either positive or negative or at 0, okay? So if we go back to our function here, where on our graph are both functions positive, okay? So here it's obviously going to be, it's not going to apply. If we look between points A and B, that's not also going to apply. But if we look at points from B here, right? And then we go towards the left, we can see here that both of our functions from B, right, where B is the x coordinate there is minus 3. Sorry, it's minus 2. For x less than or equal to minus 2, we see that both of our functions are either at 0, where x is minus 2, or positive, you see. So that is basically it for that question. So I want you guys to try it out a bit, look at other use cases, and try and see if you can come to a similar like understanding, right? So now let's finish off with our last question. So in our last question, we want to find the length of AK. So AK goes from here all the way to that point up there, okay? So we want to find AK, okay? But how do you go about doing it? We can use Pythagoras theorem, right? So we can find the length from A to B. So let's do that, okay? The length from A 2b is equal to what? So what's the difference? It's going to be 2 minus 2. So the length there is 4. Next, we want to find the length bk. Okay. So for bk, let's see, right? So the coordinate of k, we can find it, right? Let us see. We know that at that point B, x is minus 2, right? So let's substitute that minus 2 into our straight line. So minus 2 plus 2. So this is equal to 4. Okay. So now we have 4. So that's the y coordinate at k, right? Minus 0, because at b, y is 0. So that is also equal to 4. So we've got a, b, and bk. Now we want to find ak or ka. Okay. So now ak is equal to the square root of ab squared plus bk squared. And what is that equal to? So we'll have 4 squared is 16, right? So 4 squared plus 4 squared, and this is equal to root of 32. So that is basically it. So from this video, you should have learned a few ways of tackling such questions, right? When it comes to functions. For this video, we tackled parabolic and linear functions. We found coordinates for different points. We're able to study the sketch and basically find intervals where a function is above 0, etc. So I would like you to review this video, check it out for yourself if it makes sense. And if you like it, please give this video a thumbs up. But thank you for joining, and till next time.